Advantages of laser scanning for your project. Safety. High-definition laser scanners collect data from a distance, eliminating the need for a technician to physically contact the features being measured. This greatly reduces the occurrence of dangerous and risky situations and keeps technicians from interfering in the normal operations of the work environment, such as traffic or the movement of machinery. Efficiency and volume. Scanners collect millions of measurements on every feature within their range and line of sight at a rate unmatched by other methods. This thorough data collection process eliminates the need for return visits to sites. Everything scanned is archived so that additional data can be harvested from the scans as the need arises. Accuracy. Extremely accurate models can be developed due to the volume of individual point measurements. The accuracy levels of the modeled scan data can exceed those attainable using other methods. The scanning system doesn't require a technician to manually target the areas from which data is collected, thereby greatly reducing the human error factor. The scan clouds can even be registered to the site control systems, making the data integration and translation to other site data a seamless process. Visual impact. Not only does the scanner collect data on the site features, but this data is presented as a virtual model, referred to as a point cloud, which is comparable to a photograph. Every point in the cloud is a dimensionally accurate visual representation of the site. This visual streamlines the flow of information between those working on site and other remote support staff. Visual deliverables. Fly-through videos. Fly-through videos are generated directly from the scanner software and can be used as virtual tours, walkthroughs, or in-depth visual analysis for things like site distances or visual impediment impacts. Transitional videos. Another type of video deliverable is a transitional video, which shows the step-by-step transformation of site conditions, essentially a before and after comparison. Examples of this are shown later in this video. Many other types of visual deliverables can be created to demonstrate different things, from settlement deviations to communicating changes and markups. These types of deliverables include color-coded elevation and deviation maps, markup drawings, annotated dimensions and measurements, slideshow-type presentations, static screen captures, and many others. Virtual survey. One of the most common types of deliverables for scan data is the virtual survey. A virtual survey uses the scan clouds to identify and code features to create a point file and/or line drawing for use in CAD programs. Virtual surveys can provide a higher volume of accurate data than conventional surveys. Measurements collected by the scanner are directly reflected off the surface of the target object. Sources of error such as instrument and rod measure-ups, plumb and level targets, and differing prism offsets are nullified. Data points generated in the virtual survey files using the scan software are the same types of files created by other survey methods, and therefore translate to CAD and other design platforms as easily as the files currently being used. Overhead lines, curve and edge identification. Edges and curves of objects observed can be identified and modeled to find an exact location of those objects. Lines and other objects are created along these edges and curves to export into CAD, design, and modeling programs. These tools are demonstrated best when it comes to overhead utility lines. Because the lines between support poles and towers form exact arcs, the sag points can be identified with high levels of accuracy for the calculation of elevations and clearances. This process is much safer and more accurate than other conventional methods. The lines are measured directly without the potential for contacting the lines or the need to use lifts or cranes to position workers to measure these features. Distance measurements. Many types of measurements can be made directly from the points, which can be annotated in the cloud or exported into CAD for markup drawings. These include several types of distance measurements, like point-to-point measurements. Dimensions are extracted from the scan cloud between any set of two or more points, providing highly accurate and controlled measurements between these features. Point-to-surface measurements. Distances can be measured from any point perpendicular to an established surface. This is extremely useful for calculating fits and clearances between objects and fixed surfaces such as the ground or walls. Direct vertical caliper measurements. Vertical distances can be measured between the surfaces or points of any two objects. This is useful for calculating vertical clearances and height restrictions for sites with overhead crossings and restrictions like bridges and overpasses. Alignments and cross-sections. Horizontal and vertical alignments can be either created within the point cloud or imported from an external source. The alignments can then be used to generate cross-sections and surface profiles, or relate scan data to the station and offset information in the site plans. These alignments and sections can be imported and exported directly to and from CAD as 3D lines and polylines to help create and harvest information relating to surface profiles and to reduce the amount of data to be transferred. 3D models. Many types of 3D models can be generated within the scan software directly from the data in the point clouds. These models range from simple surface patches and tin meshes to geometric shapes and even complex structural steel pieces, piping sections, and fittings. Highly accurate planar surface patches can be generated for objects like walls and floors for the recreation of buildings and other structures in CAD and other modeling platforms. Tin meshes can be generated for complex ground and other irregular surfaces. These models can be imported into CAD and can be used for surface comparisons like volume calculations and analyzing deviations from existing grades to design grade. Geometric objects and shapes can be generated directly from the scan software to model things like boxes and cylinders for columns. These objects allow for accurate measurement and locations of these features and can also be exported for use in design and CAD software. Complex objects like standard steel sections such as I-beams and box girders, piping components, and fittings can also be created using the scan software tools. These models can be used to generate accurate center lines and edges from which data can be extrapolated in instances such as locating the edge of a girder on the top of a bridge deck with information gathered from below. Photo draping. Photographs collected at the time and location of the scans can be used to generate a photorealistic texture map for the point cloud, providing a more detailed and easily recognizable image of the site. This is helpful in relating the point cloud to the physical site and provides a visual aid for processing the scan data. Interference cleaning. Tools within the scan software provide for removal of errant points or temporary obstructions from the point database. This noise can be caused by a variety of things that disrupt the scans, such as traffic or pedestrians passing through and creating false points in the cloud. Easy removal of this noise enables us to efficiently collect and process scans without having to worry about stopping to allow people and cars to pass, and allows us to provide a cleaner set of data for our clients. As you've seen, 3D laser scanners can provide information that previously was unattainable or inherently inefficient by other established methods. The quality of this data and the efficiencies of the workflows can make scanning an extremely viable and economical option for many types of projects in today's world. With the inflow of 3D technologies in the design and construction professions, high-definition laser scanners are rapidly becoming the best tool for measurement and recording tasks on many job sites. Here at White Shield, we have adopted the latest in scanning technologies and software to perform virtually any measurement and modeling task for your project.